So for our first example, we are going to look at understanding the trigonometric ratios using similarity. We just finished a whole similarity unit, so we're going to relate that to our new material. Our question is, how are the sines, so our sine function, of two different angles with the same measure related? All right, well, first, let's determine if we have similar triangles. I can see that angle C and angle F are congruent because those are both right angles. And then angle B and angle E are both x degrees. So whatever x is, I know it will be the same. So we do have similar triangles by your angle-angle similarity. So we'll just make note of that. Triangle ABC is similar to triangle DEF by the angle-angle similarity. All right, so now that we've determined that the triangles are similar, that means that all the sides are proportional. All your corresponding sides are proportional. So they did want us to look at the sines of two different angles with the same measure. So angle B and angle E are not the same angle, they're in different triangles, but they do have the same measure. So we're going to compare the sine of angle B and the sine of angle E. So when you have to set up your trig function, we're going to say sine of angle B equals, and then let's remember SOHCAHTOA. I tend to write it out like this. You guys might prefer the other way. This must be how my teacher taught me when I was your age, learning about SOHCAHTOA for the first time. Because we're talking angle B, we need the opposite side and the adjacent side. So opposite side is across the triangle. Sorry, not the adjacent. Opposite and hypotenuse. Here's our hypotenuse. So when we set up that ratio, our opposite side is side AC. We're going to put that over the hypotenuse, which is side AB. All right, now let's find the sine of a different angle that has the same measure, sine of angle E. The opposite side is, right here. Here's our hypotenuse. So we'll set up that ratio. The opposite side is DF, and we will put that over the hypotenuse of DE. All right, so AC over AB, that ratio, because these triangles are similar, will be equal to the ratio of DF over DE. Because they're similar, we know that this is true. So if those are true, that means that the sine of angle B must be equal to the sine of angle E. Because we know that sine of B is equal to this, sine of E is equal to this. Well, if these are the same, then sine B must equal sine E. And so in conclusion, what we are learning right here is any two acute angles with the same measure So in this case, angle B and angle E are acute, and we can see they have the same measure. Will have the same sine. Maybe we'll throw the word value, the same sine value.